Hello, this is Rich Lavens of Eurotherm by Watlow, and I have had the same question a couple times this week, and that question is, can I do flow totalization on a Eurotherm nanodac? And the short answer is, yes, you can. So from a hardware setup, what I've got here is I've got a signal generator, and I'm pushing a 0 to 10 volt signal into input 2. So that's the hardware. So again, you can use a 4 to 20 as well. And then my signal generator is set up for voltage. So I'm going to feed in 2 volts here. And then we'll scale that so we have some results on the nanodac. So let's just put in 1 volt for now. And I'm going to scale this 0 to 250 gallons per hour. So at 1 volt, it should be about 25 gallons flow. So let's go to iTools, and I'll show you how to set this up using the iTools configuration software. Okay, so I have got my nanodac connected to my iTools over Ethernet. You can also do it by way of the CPI clip. So what I have initially is just a normal temperature loop. So again, we're going to go through this and it'll do a temp loop. But if I simply want to do a flow totalization, what I'm going to do up here, and this would be up to you, but I'm going to create another page using this compound. So create a compound, and I'm going to click it. And then I want to drag in channel 2, which is where my flow is coming into. It's going to ask me for a password. So there's my channel. And up here, we're going to double click on the gray header. And it will open that, that function block. So here, up here, the type of channel, it can be, again, different choices. But in my case, I want to use voltage. I've labeled my input, my flow input. My descriptor can be anything you want, gallons per minute, gallons per hour. But in our case, we're going to do gallons per hour. This is where you run this is what you tell the nanodac what your electrical input signal is. So here, I'm going to feed in a 0 volt on the low end and a 10 volt for the maximum, so the low and high. And then what does that represent? Well, I want that to represent at 0 volts, 0 flow, and at 10 volts, 250 gallons per hour flow. So that's my setup on the input. And if I come into this trend, you can pick different colors for the trend line. You can set up alarms and so forth. I'm not going to do that here, so we'll just go back. So that's the setup for the input. We'll go back to our graphical wiring. What I want to do here is, this is great. It's going to show you flow, but it's not going to totalize it. So I'm going to come down here to what we call a virtual channel. I'm going to drag that channel out here. And we'll double click on the gray header. Now, by default, this is basically set up as a math. So again, I've labeled it flow totalizer. We're going to select the totalizer function, and we're going to turn that on. So in there, we can have the lowest input value and highest input value that'll totalize. I'm not going to set that up. So really, this is kind of set up now. And here's the period. Let me expand that just a hair. Here's the time period over where the calculation is made. So we can look at this every 1 second, 2 seconds. We can scroll down. So in my case, let's just do 10 minutes. And then we'll come back to graphical wiring. And we want to take that main process value and put it to the input of the totalizer. And then I'm going to grab a couple monitor blocks just to see if everything's working right. So there's that. So again, based on that 1 volt signal, we're reading really close to 25 gallons per minute. And then we can monitor the totalizer output. So right now, not much flow happening. And then lastly, this again, just a little tip. So on these tabs, we can rename these. So this is just called compound at this point, but if I right click anywhere on the page, I can rename that. So let's just say flow total. And I'm sorry, that popped up on my other monitor, but that's what I'm filling in. And when I hit OK, it changes that tab up at the top to flow totalization. And then we are going to hit the download wiring to instrument block. So it's going to save this wiring, and that's right here. So we're going to click that. You'll see it saves the wires. And now you can see we're starting to get a little bit of totalization here too, which is good. So the other thing we want to do is this is working in the background, but we need to tell the nanodac to display this properly. So we're going to come to our parameter explorer here. And there's different folders and tabs over here, but what we want to do is go to our group tab. And we can name this whatever we want, group 1, so forth. And what do I want to look at? Well, my first channel is the temperature channel I already had set up. Channel 2 is my flow. So again, that's the actual flow rate. But if I want to look at the totalized flow, we're going to come back in and we're going to grab, show you this. We want to look at virtual channel number 2. So back to my parameter explorer. We want to look at virtual channel number 2. And now it will display that as well. Now the trend is basically the display of the nanodac. If we want to record that, we're going to pop back here. We're looking at channels 1 and 2 already. But then down here, I don't really care about this. So we can shut this off. That's virtual channel 1, which is not being used. And we can turn on, oops. Down here, you can see that virtual channel 2 is enabled. So now we are going to log temperature, flow, and totalized flow. We'll take this out of configuration or access mode so the controller actually does something. And there we have it. So now I'm going to go back to my signal generator and let's put in 2 volts, which should be close to 50 gallons per hour. And you can see at 2 volts, I am reading really close to 50 gallons per hour. And now my flow totalization should increase because I've got more flow. So that's the basic setup. Within the virtual channel, let's go back into access mode. I'll show you a couple other things. In my case, I'm going to reset the flow back to 0 when this thing resets. And I can do a couple other things here too. So we could, if we wanted to, tie this to a real-time clock. So here's a real-time clock. Let's set up an event. And we're going to do time and day, and we're going to say every day at 11:59:59. So right before midnight, basically. I guess actually be 23:59. 23:59. So right before midnight or right at midnight, we're going to get a pulse out of this timed event. Back to our graphical wiring. When that outputs, we can tie this up here to go back to the preset. So that will go back to basically 0 totalization on that, and the process will start all over again. So now let's go back to our nanodac, and I'll show you the display on that. Take that out of config mode. Okay, so we're back at the nanodac. Over here, you can see my signal generator is putting out 2 volts. I've got a thermocouple hooked to it, reading about 70 degrees. So if I hit the Enter key, now here's my flow input based on this, 50 gallons per hour. And you can see the color's blue. That's the color I selected. We're going to hit it one more time. And then there's the totalizer in a little bit darker blue. So again, I can ramp that up a bit. Let's just go to 2.5. It's 2.5. You can hit that button again, and you can see my flow has increased. So anyway, that's how you set up a basic totalizer function on a Eurotherm nanodac. I hope you find this video helpful, but please drop us an email or give us a call with any questions. Thank you.